Hey, welcome back to a Moonbeam workshop. This is going to be on the Foundry developer environment. This will loosely follow the tutorial that is on the Moonbeam documentation site, but it's not going to be, a full-on, well-edited tutorial. There will be mistakes, there will be potential rambling, and we'll just go through this casually together. So, you are encouraged after this video to check out our documentation site because the tutorial there will be going in a little bit more depth than this video, and it's good to get more of a written approach along with a video one too. So, there are a couple of reasons that we're going to go over Foundry today. Because Foundry is an increasingly popular developer environment. It's there to generally replace the Truffle / Ganache or even Hardhat environments, even though Hardhat is quite possibly the most popular developer environment right now. But as I said before, it's increasingly popular because it's generally considered to be faster. Tests in Foundry are considered to be and have seen to be up to 10 times faster than when written in JavaScript. And Foundry can do this because it allows for less context switching. So the thing about Foundry, as opposed to all the other developer environments that exist, such as the Ganache, Hardhat, and Brownie ones, is that they all use different programming languages for their tests, for their scripts. But in Foundry, everything is written in Solidity. And this is helpful because then you don't have to use a library like Ethers to act as a middleware between the scripts and the tests that you write and the smart contracts and the nodes. You don't have to know different languages, you just need to know how to write smart contracts. Everything is in a single unified context, Solidity. Now, Foundry is written in Rust. That's why it's under Foundry RS. And, that, for some Rust maximalists, just make it automatically faster. It's okay if you don't know Rust. But it can be helpful if you're familiar with components of Rust's environment, such as TOML files, as opposed to JSON files, which are more prevalent in JavaScript. So you will see a bit of a paradigm shift if you're hopping from a JavaScript developer environment to Foundry. So Foundry is really a tool suite, not a tool in of itself, because it consists of 4 developer tools. Forge is essentially for smart contract development. It's called a testing framework, but it also compiles and so on. So, it's very similar to, as it says here, Truffle, Hardhat, Brownie, major on-suite of commands that you will use. Second, we have Cast, which, as they say, is a Swiss Army knife for interacting with EVM smart contracts, sending transactions, and getting chain data. Essentially, it is a CLI to interact with nodes, to send transactions, to call contracts. Anvil is the third. It is essentially a local Ethereum node, like Ganache or the Hardhat network. You can use it for forking nodes as well, such as if you wanted to test out that already deployed contracts on Moonbase Alpha or Moonbeam, then you could fork it with Anvil and then do everything on a local node instead of having to actually try those transactions out yourself on the testnet or mainnet. And finally, we have the newest one, which is Chisel, which is a fast, utilitarian, and verbose Solidity REPL, which is, I think, a read, execute, and print loop. Essentially what it is a shell that allows you to write Solidity in the command, in the command line, in the CLI, and it will execute it, and it will allow you to test these small snippets of Solidity code in case you want to really get familiar with how certain pieces of the EVM and development with the EVM works. And it can be very helpful if you're just trying to test out a small part, maybe figure out like gas efficiencies and whatnot, or how data structures work, instead of having to go into Remix and set up a whole file, a whole contract, or use ethers or something like that. So very useful. So to start off the tutorial, the actual development part, we're going to be using Moonbase Alpha, our testnet. You could use a local dev node, and that's very useful in case you want to, work without having to have a faucet or have very long wait times for, finality or just getting transactions included in blocks. It's very useful for testing, but that's going to require some extra setup, Dockerization and so on. So we're going to go over just Moonbase Alpha because that's the simplest to work with. But I do recommend using it if you want to. We have guides on that on our documentation site. But instead, we're just going to be using Moonbase Alpha. So we're just going to use the Moonbeam or Moonbase Alpha endpoint. So if we go into Moonbase Alpha, and we can say getting Moonbase Alpha testnet. That's not the right one because it's under Learn. Moonbase Alpha. I like this one. Get started with Moonbase Alpha. Here we can see the available RPC URLs, which will allow us to communicate with the node. Now you can get your own from Blast, on Finality, Pocket, some other provider, United Block as well. There are many other providers that you can make an account, get your own node, you get your own private endpoint for your own private project, and I recommend that you do that. But for now, we're just going to be using this public one that's provided by the Moonbeam Foundation. So the next step is to set up a wallet that we're going to be interacting with in Foundry, or with Foundry. So I have a wallet here called the Foundry Testnet wallet. I just made it in MetaMask, and I'm going to use this wallet to interact with smart contracts, deploy smart contracts, and so on. So to do that, first I need Dev, which is the native currency for Moonbase Alpha. So what I can do is I can search for the Moonbase faucet, and I should get it eventually. If I just search for faucet. There it is. Same page, but we're not going to talk about that. Okay, and you can go to the Moonbase Alpha faucet website. We can get our wallet's address, slap it in, say I'm not a robot, bus. Submit. And after a while, I should get some dev. So if you look here, we'll probably skip. Okay, and there we are. There's 1.1 dev that arrived in our wallet. So now we have this, and we can now actually start using Foundry. We have all the setup finished. So if I go into here, I can go into my desktop because I want to make a project on my desktop. So the first thing that we need is Foundry installed on our computer itself. Now I'm going to assume that you're using Linux or Windows, because while you can use Foundry on Windows, it does explain how you can use Foundry on Windows on their GitHub repository and in their book. It's more difficult because you'll have to install from source. You're going to have to use Cargo, so you're going to have Rust installed. You're going to have to use Docker, and generally, when you're building on Windows with Rust, it can be slow and painful process. So you can follow this tutorial on Windows. It's just going to be a little bit more difficult. But if we are fortunate enough to do it on Mac or Linux, then we can just use this command here, and this will download it and install the Foundry up executable, and we can just run Foundry up, and this will install it for us, install the nightly version. I've already downloaded Foundry, so it was a pretty quick update, but it shouldn't be too long for you. And that's it for installing. Now we want to make a Foundry project. So to do this, we would use the forge command. As I said before, forge is the tool that we'll be using the most. So forge init, and I'll just say Foundry workshop. So we're initializing a new project called Foundry Workshop. And so now we're installing Forge standard library into it, yada, yada, yada. And if we go into the Foundry Workshop folder, which has been created for us, we now see a whole bunch of files which has been generated for us. So I'm just going to open up the VS Code editor, and then we can see what it has for us. I'm going to close this because we have VS Code open now. Okay, so a couple of things here. You might notice that there are some Git files here already. We have a git.gitignore, .gitmodule, .github. If we open up the command line, you'll see that we have, if we use git log, you'll see that we have a bunch of commits already. And that's because the forge init command already creates a GitHub or a Git project for you. If we look at some of the other folders, we have lib here, and lib is all of your packages. It's your library. And so, as we saw before in the command line, we have forge, std, standard library, installed automatically. Under scripts, we see all of our Solidity scripts, which is how we deploy and interact with already deployed contracts. And we have source, which is all of the source contracts. So these are the real contracts that we're going to be deploying and using on our Moonbase Alpha testnet. And then we have the test contracts, which help test our project. Okay. So now that we have everything set up, the first thing that we want to look at is the Foundry config file. And that is Foundry.toml. In my opinion, this is one of the more confusing sections of Foundry if you're coming from JavaScript, because unlike JavaScript, we don't use JSON, we use TOML files. Learning about TOML files might be a little bit more difficult because you may not have never used them, and especially figuring out which configurations there are might be difficult. But Foundry's book has a bunch of different references for it, especially if we go to the config reference. We have a bunch of different sections where you can see, we can set up Etherscan keys, we can set up like the compiler, various issues with the project and so on, testing, formatting, even documentation generation. And so you can look through this yourself if you really wanted to configure your project to the greatest ability that you wanted to, get really fine-tune it. But instead, what we're going to do is go and simply add Sol C version here. And what this does is set our Solidity version to 0.8.18. And this is one of the features that you might use more often. Another feature that you might use in the Solidity or in the Foundry configuration file is the section RPC Endpoints. So this is how you define the different networks that we're going to be using. So in this example, we're only going to be using one network. So we're going to say Moonbase is equal to, and then we're going to go back to our Moonbase Alpha documentation site, get our RPC URL, and paste that in. So now whenever we say the word Moonbase for RPC URLs, it knows that it wants to use this URL, and you can input whichever RPC URL in there that you want. It could be your own, again through Pocket, Blast, etc. Okay, so let's save this file. It's already saved. Let's save this file, and let's start getting into the meat and potatoes of writing contracts with Foundry. As I said before, all of the contracts are in the source folder. Here they've already generated counter for us. So let's just make a token, right? So MyToken.sol. Okay, and in turn we'll name this MyToken. So we have a MyToken contract. Now, when you're making a contract that is a token in Solidity, typically what you want to use is OpenZeppelin's standard library. Now, if we were using Hardhat or some JavaScript environment, then we would use npm, the node package manager. We do npm install contracts or at OpenZeppelin/contracts, right? Unfortunately, we do not have that here. We do not have node modules. Instead, we have lib. So what is lib? How do we get the OpenZeppelin contracts? Well, it's actually quite simple. There's not like a separate package management system that's specific for Foundry. Instead, what we're using are Git submodules. So, to install a Git submodule, you would use forge install OpenZeppelin, specifically for OpenZeppelin, and then OpenZeppelin contracts. Okay, you'll probably get this error as well when you try this out. So we've initialized a repository, but there are issues, and we want to resolve those issues. Well, not issues, but they're uncommitted changes, and we want to resolve that before we add more submodules. So let's do git add dot for everything, git commit renamed MyToken, and I think that should be it. Okay, let's go back to our forge install command. Forge install. So it's installing OpenZeppelin contracts in our lib folder. Now you might wonder, how did I know to write OpenZeppelin/OpenZeppelin contracts? Where is that defined? Well, if we open this link here, we'll find that we are linked directly to GitHub. And look at that, OpenZeppelin/OpenZeppelin-contracts. So when we're working with Git submodules, we're basically taking them from GitHub and saying, okay, this repository, I want that on my project, and it'll be a dependency now in my project. So if you go into lib and we see, in VSCode they're going to be blue for submodules. If you go down here, we see everything inside of the GitHub repository. And so that's basically our package management system. And so when we want to use a contract, they're under the contracts folder. There's token, ERC20, exactly what we want. Okay, so let's import that. So if we want to import a contract, very simple, import ERC20 from OpenZeppelin contracts/contracts/token/ERC20/ERC20.sol. Let's just make sure that that's what we want. OpenZeppelin contracts, token, ERC20, ERC20.sol. Okay. This doesn't really change very much yet, but just to make sure that we're compiling, I will use forge compile. Or counter not. Okay, all right. So here's the thing about everything being Solidity is that it has to compile everything. So in these other folders, we have script and we have test, and they likely expect the counter contract to exist, but now it's called MyToken. So we're going to instead, here it is, test. Instead, we're going to just comment out some of this stuff. We don't need this anymore, and we'll come back to it later. /compile, compiling 25 files. Great, compiler runs successful. Now, if you're running this for the first time and you're used to doing hard hat stuff, or Nash or anything with the node modules, JavaScript environment, then you might see a red squiggly here. And to fix that, what you can do is you can go into your extensions, search for Solidity, and Solidity, yeah. And I'm using the one by Juan Blanco, I hope is how you pronounce it. I'm sorry if I butchered it. And you go to the extension settings. You'll be able to see, okay, this is the remote version that we're going to use to compile. Great, 0.18. But all the way down here, we can say, okay, the package default dependencies directory should be lib for node instead of node modules. And this will be saying, okay, we're going to be looking for lib for all of our dependencies instead of node modules, and that'll get rid of our red squiggly if it's there. But it's not, because I have it configured correctly, and you can keep on going. So let's now just write our contract. So inheriting from ERC20, my token is an ERC20. Okay, big surprise, big surprise. Get a red squiggly because our constructor doesn't use it yet, so let's create a constructor. And in this constructor, we can just say, like, if we wanted to mint an initial supply, let's give it a number, going to 56 initial supply, and then ERC20, let's name it my token, and then give it the awesome tag of my talk. Okay, and then since we want to initially mint a supply, we can just do mint initial supply to, message to sender to mint to the sender of the message, the initial supply. Okay, and we can get rid of these because they're not relevant anymore. Should compile. Awesome. Finally, let's add one more function that we'll be using later, which is just an external mint function. Mint uint 256, the amount to mint, and address 2. Well, let's actually rename this to amount, and we'll call it external because we want other people to be able to call it. For demonstration purposes, let's add a require. So we'll ensure that 2 mint is less than or equal to 1 ether. So we don't want people to be too greedy per transaction, right? Or rather, amount to be less than 1, less than or equal to 1 ether, and then we can just do that with the normal mint. So that's just a sender and mint, or rather 2. Okay, great. So now we have our MyToken smart contract, and this all works as expected. If we compile one more time, very, very fast compilation time, and it compiled as we expected it to. So let's move on to some tests, because we want to test our new MyToken contract. So let's go to the counter.t.sol file, and well, we don't have counter anymore, so let's just rename it to MyToken.t, the T indicating that it's a test. Okay. And inside of this file, we're getting a red squiggly. We'll fix it. We might fix it later, but just trust me that it works. Inside of this file, we want to import the MyToken contract so that we can test with it. So if we go here and do rename it MyToken test, great. Everything's standard now. Let's uncomment this. Rename it from MyToken. Rename it for counter to MyToken. We'll call it, let's just call it token. And this is so that we can store instances of the token while we're testing. The next thing to uncomment is setup. Now, setup is ran before every single run of a test. So these tests here, we have 2 tests here. Setup would run before each of these tests are run. And the reason we might want to do that is because we want to, have a default token contract generated each time, a new fresh slate. So let's do that. Let's generate a new token contract. And we don't need to set the number because that doesn't exist anymore. The only thing that we really need to do is give it the amount to mint. So it's 100 because, as you remember, in the constructor, initial supply, this will be our initial supply, 100. Okay. So what do we want to test here? We can test just the initial supply first. So we can uncomment this function, or actually let's just write our own functions. Let's just do a function test, and it has to start with the word test in order for Forge to know that it is in fact a test. And it will be test constructor mint public, so that the testing suite can find it. Okay, so we know that this is a test, and we know we want to test the constructor mint, and we expect it to be 100. So we can just call our token, token dot balance of, and address of this, because it is this contract that minted or deployed the contract. So this is what we want to test. Now, how do we test it? Well, if we look, test right here is a contract that this test contract inherits from. Where does test come from? It comes from the Forge standard library test. So let's go there. Forge standard library. I believe it'll be in source. There it is down there, test. Test inherits from ds test, which comes from ds test / test.sol. Okay, let's go there under this library, ds test, source. I'm going to assume it's in test.sol. There it is, ds test. Now, ds test is a library that was written before Foundry, I believe, and it was another testing framework that's based completely in Solidity. And it has a bunch of assertion statements. Assert equal, assert true, assert that it's equal to a number of decimals, right? Assert greater than. Lots of assertions that you can use. So we're going to use those assertions. So we want to assert that the token balance is equal to our constant 100. And that's it for the test. That's it. So let's compile. Let's use Forge compile. Okay, so everything's running. And I can just run Forge test. As you can see, that was really fast. And it finished in 3.66 milliseconds, and it knows for sure that yes, it is equal to 100. Okay, let's do something slightly more complicated. Let's assert that. Let's assert with a fuzzing test. Okay, so if you're not familiar with a fuzzing test, let me explain. So typically when you're unit testing, you're looking for edge cases and a couple of good example cases that an everyday user would have or encounter, right? But what if you don't know all the edge cases, right? How do you know that you've encountered all the edge cases? Well, this is where fuzzing comes in. Fuzzing bombards your test with a bunch of different values, instead of just hard coding a single value. So let's say we wanted to test or fuzz test this mint function, and we want to fuzz test this amount value. And looking at this code is kind of trivial. Yes, it's always going to work when it's below or equal to 1 ether, and it's going to fail when it's greater than that. But we want to assert that that's true with our fuzzing test, just for an example. So let's create a new test function, test and we want to ensure that it works below or equal to 1 ether. So test mint 1 ether or below. Public, like the last function. Okay. So how do we turn this into a fuzzing test? Well, all we have to do is insert something into the function, a parameter into the function. So uint 256 amount to mint. Sure. So adding like a uint or a string or bytes or something automatically creates this fuzzing test. This is now a fuzzing test. So we can just take our token, token dot, we're going to assert, well, actually, we're going to just test, yeah. Let's assert that when we mint, so token mint, and we're going to mint to the message test sender, why not, that the amount to mint. Okay, so we mint that, and we want to assert that the amount minted, so token.balance of the message at sender is equal to the amount that we wanted to mint. Okay. Well, this all compiles, right? Okay, great. Compiles. Ooh. What's this? Oh, I switched it around, I bet. How about now? No. What am I doing? I switched it around here. Of course, the equality is gonna work regardless. Okay, so that's the problem. I switched it around here. Awesome. That might have been the third try, so third try's the charm. Okay, so now we're asserting that the amount that we mint is always going to be equal to what we get out of it. So let's test that. Forge test. Oh no, it failed. So what could be the problem here? Well, when we run with this much, which looks like to be just 1 above an ether, I believe, we get a failure. And that's expected because 1 ether, because that's above 1 ether. Great, so that works as intended, but we want a green, pass, and we want to ensure that it's 1 ether or below, as the test said. So let's use something that Foundry gives to us to work with. And that is the cheat code, VM. So what's the VM cheat code? VM means virtual machine, so we are kind of changing the virtual machine. This is how we tell Foundry/Forge to change things in the way that we're testing or in our developer environment or how we're deploying. And so with VM, we can assert or assume, rather, that the amount that we're going to mint, is always going to be less than or equal to 1 ether. Okay. So this is like putting a limitation on our fuzzing, essentially. So if we retry this test, forge test, okay. Now it always passes because the amount of ether is always less than or equal to the amount to mint. Let's try this one more time, but with the rest of the tests, right? So we've only done 1/2 or one part of all of the possible values. We want to get all of our edge cases. So function test mint above 1 ether. Okay, and we'll also give it an amount to mint because it's also a fuzzing test. Public. Okay. This time, we're assuming that the amount to mint is greater than 1 ether. Okay. We can just copy the rest here because here we go. We don't need this. I'll show you why later. But we're going to assume that the amount that we're minting is above 1 ether, as our function says. Let's test again. Force test. Well, as we expected, this failed because that's what we want. We want it to fail. But this failing essentially means that it's passing, right? So we're really testing for a failure, not a pass. And so while this red here is expected and that's good, really it is a pass in our use case. So we're going to name this test fail. We're expecting it to revert. So let's try one more time. Forge test. Great. Now all 3 of our tests pass. Okay, now I want to go over the last section of Foundry today, or Forge today, and that is the scripts. So typically scripts when working with a blockchain are written in JavaScript or some other language, but in here, in Foundry, they are written in Solidity. So here under the script folder, I'm going to rename our default script to MyToken.s. S stands for script. So MyToken.s.sol. I'm going to put that to 18 instead. Okay. I'm going to rename this to MyToken script. And it is a script imported from the Forge.toml library. Like usual, you can use setup to run before everything else, but we don't really need that, so let's delete that. And what we want to do here is deploy. So we want to deploy our contract onto Moonbase alpha. Right? So how do we do that? Well, think about what you need to send a transaction to a testnet or a mainnet. You need a private key for a wallet, and then you need to be able to construct that transaction, sign it, send it. So let's start with the first thing. We want to get a private key. Now, if you know anything about development on blockchains, is that you want to hide your private keys. But for this instance, we're going to show you the private key here in MetaMask, specifically for the Foundry testnet wallet that I prepared for this video. Never show your private keys to anyone, but in this case, it's going to be thrown away later. So let's look at these account details. Export the private key. You're not gonna be able to see my password, but here we go. This is the private key. So let's put that in safekeeping over here. We'll come back to it later. Now, typically, when you're working in a hard hat environment, you would import it from environment variables. How do we import things from environment variables here? Well, we're not going to have a .env file, but we can still, make environment variables by using, just commands in the command line. So, assuming that we put our private key into the environment variables, we can get it by using another cheat code. So uint 256 deployer private key 256 because it fits in 32 bytes equals virtual machine dot environment and interpret it as a uint. Environment env uint, and then we're going to assume that it's named private key. This is a little bit safer than just simply putting it into the CLI or something. Okay, and then what we can do is start a broadcast. Now what's a broadcast? So when we start a broadcast with this private key, what we're essentially saying is, okay, from here on out, everything that we're doing is going to be on the mainnet. All this logic beforehand all of that, if we had a setup function, right, all of that beforehand is not run on the testnet or mainnet that you're deploying to or interacting with, because that saves on gas. Essentially what's happening before here, it's not actual Solidity that's running. Instead, this is Solidity language that's being interpreted by Rust and then turned into, actual commands. In like assembly on your computer. But everything after the broadcast, this can cost actual gas. So what we want to do is make a new token. So MyToken token is equal to new MyToken, and we want to make 100. And we forgot to import it up here, so let's import it. /source MyToken.sol. Okay. And then finally here, vm.stop broadcast, because we want to ensure that it stops. And we don't want to ping more gas than we have to. Okay. So this is a pretty simple script, but at least it helps you get an understanding of how these VM cheat codes work. Okay, so let's use this script, but first we have to set up our environment variables. Let's create a .env file to store our folders or our private keys, because that's basically convention. It is ignored by our .getignore file, so let's ensure that we're using the same name. Private key is equal to what we stored before for our wallet. Okay, and we can always describe more private keys. So other key is equal to test, right? And so we would be able to use the source command source.env, and that'll put all of our private keys into or all of our variables into our environment variables. So if we, just to test it out, echo private key, you see that. And if you wanted to print out the other key, we should print out test. Okay, great. So we know that is working. And so we should assume that it should be able to get a uint out of the private key environment variable. So how do we write this? Or how do we run this? Well, once again, we use a forge command. Forge, not frog, forge script MyToken. Well, let's first make sure that we're in the right folder, right? So we want to be in the script folder. So /script/MyToken script, or MyToken.sol, sorry. And inside of this folder, or inside of this file, we want to specify the MyToken script, because we can put multiple contracts in a single file. So we're going to specify MyToken script. We want to indicate that we want to broadcast, so we're enabling broadcasting. We want to be verbose, so you can add VVVV to any forge command to get more information as to what's happening along the lines while it's running. And we want to also specify where we're going to be running the script. In this case, we're doing it on Moonbase Alpha. So --RPC URL. We don't have to give it a URL because we've already defined that inside of our Foundry config folder. So Moonbase. Okay, let's see if this works. Okay, compiling. It's tracing. It's running. Ooh. Okay, so we see the simulated on-chain traces. Okay, this is what's happening. There's a transfer because we're minting. Okay, it thinks that it can work. It tells us information, chain 1287, which is Moonbase Alpha, so far so good. Here's our gas price. It says ETH instead of dev. That's okay, same thing. And there we go. The on-chain execution is complete. It's successful. It gives us information on what we paid, and the transaction is saved under broadcasts, and you can get a bunch of information on it. It's in run latest, so here's the hash. You should be able to see here in the address here, or in the output here, and we should also see the contract address here and right there as well. So let's just take that contract address, verify by going to moonbase.moonscan.io. Does it actually exist? Yes, it actually exists. It was made 58 seconds ago, so success there. Okay. That's about as far in depth as we're going to go with the Forge tool. There are other tools such as Anvil, which might be helpful. Anvil is very, very simple to use. You just write Anvil, and just like that, it has created a local node for us to use. Gives us all the private keys so that we can import into different wallets, different accounts that we can use. Just a local node. We can also fork with it. So we do have a guide on our documentation site. If you search up Foundry, using Foundry to deploy Moonbeam, we will be able to fork Moonbase Alpha or Moonbeam or Moonriver, any of the Moonbeam networks with Anvil. Very, very easy to use. Just fork the URL. Very, very simple to use. And finally, I just want to demo Chisel a little bit, which is a REPL for Solidity. So all you have to do is use Chisel or input Chisel as a command, and then you can just start writing Solidity code. So if you want to just see the output of something, such as abi.encode, and then we put in like test words, comma, 100, right? We want to see how ABI encode works, right? We can just enter, and then it gives us all the information about it. It gives us the length, it gives us the contents of the items, right? You see 64 right here, which is equal to the 100 the way we added. So you can see like, okay, this is how it packs it. Maybe this is what I want. Maybe I want to pack it differently, so on. We can see if it's different at all from encode, packed, and so on. And that's just like a single line, but you can add extra lines. So you went 250, or just my num is equal to 100, and by adding a semicolon, you've essentially defined a variable, so you're able to create different functionality or test different functionality. So if we wanted to set uint 256, my other num is equal to my num times 2, we would expect it to be 200, and we can see what my other num is equal to with some of the tools that Chisel provides, such as raw stack, because it is stored in the stack. uint 256 are stored in the stack. So my other num, we get C8, which one would hope is equal to 200, but I'm not going to do the math in my head. But it is greater than 64, so I would assume. Actually, yeah, it is equal to 200 because C is equal to 12. Yeah. So Chisel can be very helpful if you're testing out things like UL, assembly level code, if you're not very familiar with it, or if you're not very familiar with Solidity in general. So it can be very helpful. But that's as far as we're going to go for this Foundry workshop. There's still a lot more depth that you can get into, but it's getting a little long. And I encourage you to look at the Moonbase Alpha / Moonbeam documentation to really go into a deeper dive, because we do go into better tests with some of our documentation. We go into using Anvil, using Cast even. And the Foundry book is also a good place to get started as well, though it's not going to be specific to Moonbeam. And of course, that's why you're here, right? So thanks for watching, and I hope this helps you with your Foundry journey.